Hello and welcome to GeoProven and our fourth in this series of videos on transformations. The first three videos we looked at translation transformations, rotation transformations, and then reflections. In this fourth video we're going to look at composites, that is, what happens when you perform several of these transformations in a row. So you can think of composite transformations as a series of successive transformations. We've already looked at the transformations, translation, rotation, and reflections. We learned them by coordinate rules that map a point to another point, and we gave an example of a arbitrary point 7, 4 in each one of the rules and how they're mapped according to the rule. So with a composite transformation, let's look at our first example. We're just going to perform three transformations and see what happens in the order in which we take them. With a composite transformation, there's a symbol, an open circle, between each of the notated transformations. The order that these are taken is from right to left, which seems kind of strange. So the first thing we're going to do, in other words, is translate the vector with components 8 and 9 in x, 8 in x and 9 in y. So we're going to do that transformation first. Then we're going to reflect over the x-axis, which is the middle one shown there, and then we're going to rotate the figure 180 degrees, which is the leftmost. So again, the order of operations is from right to left, and you'll see the reason for that by the end of the video. So we've been working with a slice of deep dish Chicago-style pan pizza. So we're going to first do a translation, then a reflection, and then a rotation of 180 degrees. The final figure ends up there. With the ghost removed, that's the final result of those three transformations. Now let's look at a composite transformation in a different order. We're going to start with the rotation of 180 degrees. Then we're going to reflect over the x-axis, and then we're going to translate 8 and 9, 8 in x and 9 in y. So that's the exact opposite order of the transformations that we just did. Starting with the original, the first one is to rotate 180 degrees. That's what that looks like. Then we're going to reflect that over the x-axis. That's the reflection over the x-axis. And now we're going to translate it 8 and 9. And the final position is a little bit of a different place. So when we did it in one order, we got this, and when we did it in the other order, we got that. Which goes to show you that the order of operations in a transformation matters. You can't just do them in any order and get the same answer, or the right answer. They have to be done in the order prescribed. So composite transformations, the order of operations, the successive transformations matter. The transformation of rotation of 180 degrees, followed by a reflection of the over the x-axis, followed by a translation of 8 and 9, does not equal the composite transformation of the translation first of 8 and 9, reflection over the x-axis, and reflection over 180 degrees. So those orders are important, and they're not equal. So we say in mathematics that the operations are not commutative. They are not independent of order. The transformation operations we'll see in the next video can be handled by matrix multiplication. And that is to say that matrix multiplication is not commutative. In other words, if we multiply two matrices A and B, that's not the same as multiplying B times A. So again, here is a summary of the transformations that we covered. We've notated all of them by a series of coordinate rules, which can be rather difficult to memorize, I think. I think in the next video series with doing transformations by matrix, part 5 of our video series, that is, you'll see that the matrices are a little bit easier to memorize anyway. I hope you enjoyed that video on composite transformations. Please join us for part 5, transformations by matrix multiplication.